Welcome to this video on redox reactions. We will cover electron transfer mechanics, oxidation states, balancing methods, and electrochemical frameworks. Redox concepts have evolved from classical definitions involving oxygen and hydrogen to a comprehensive electronic mechanism. Remember the acronym OIL-RIG: oxidation is loss of electrons, and reduction is gain of electrons. When a zinc strip is placed in a copper sulfate solution, a spontaneous electron transfer occurs. The fading blue color and copper accumulation demonstrate that zinc has a greater tendency to lose electrons than copper. The oxidation number represents an atom's residual charge. Key rules include assigning 0 to elements in their free state, matching the charge of monatomic ions, and specific rules for hydrogen and oxygen in compounds. Using oxidation numbers simplifies tracking. Oxidation is an increase in the number, while reduction is a decrease. Substances that cause these changes are identified as oxidizing or reducing agents. We classify redox reactions into types. Combination reactions involve reactants fusing into a single product, while decomposition reactions are the reverse, breaking a molecule into fragments. Displacement reactions involve one element replacing another in a compound. This includes both metal displacement, where a reactive metal replaces a less reactive ion, and nonmetal displacement. Disproportionation is a specialized redox process where the same element is simultaneously oxidized and reduced. Hydrogen peroxide decomposition is a classic example of this phenomenon. The oxidation number method balances equations by aligning total electron increase and decrease. We assign numbers, equalize the changes, and finally balance atoms and net charge. The half reaction, or ion-electron method, splits the equation into two pathways. This systematic approach balances elements, oxygen, hydrogen, and finally electrons to reach a balanced final equation. Redox titrations are used to determine concentration. They rely on indicators, which can be self-indicators like potassium permanganate, or internal indicators like diphenylamine that change color at specific potentials. Electrode processes involve interfacial charge transfer. A redox couple consists of the oxidized and reduced forms of a substance. The anode is the site of oxidation, and the cathode is the site of reduction. The Daniell cell converts chemical energy into electrical current. It features zinc and copper half cells and uses a salt bridge to complete the circuit and maintain electrical neutrality. Standard electrode potentials are measured under defined conditions. This table displays various redox pairs and their relative thermodynamic strengths, ranging from strong oxidizing agents to strong reducing agents. In summary, remember that redox is a unified process. Use the OIL-RIG memory aid, and remember the importance of the salt bridge in maintaining current flow in electrochemical cells.